light atom move down, then the heavy atom move down. Light atom move down, the heavy atom also move down. So they have the same direction, the pair. Okay. So when omega and k increase, then the ratio of B over A also increase, just like the previous case I showed you that 2 times 0.8 over 2 minus 0.1. Okay. So when omega go to omega 1, you start from k equal to 0. What? You start from k equal to 0. When omega approaching this point, from this point to this point, when you're approaching this point, what will happen? Then A will approaching 0 since k is approaching pi over 2a, right? K is approaching pi over 2a or negative pi over 2a. These 2 points. Same. Okay, when it's approaching pi over 2a or or negative pi over 2a, then we get A equal to 0, then it's static. Okay, if you don't believe, just substitute in the previous equation. Then when A is approaching 0, that means that the light atom doesn't move, because for the light atom, U equal to A exponential blah blah blah, right? So this A is corresponding to the amplitude of the light atom, and then B is corresponding to the amplitude of the heavy atom. So when A approaching 0, when omega approaching omega 1 at this point, so you can see that the light atom actually static. So the omega 1 only involve the capital M, the heavy atom. Okay, so same equation here, omega 1 equal to this one. So you can see that this is the reason why at omega 1 is only involve the heavy atom M and does not involve the small letter m, because the A is 0, so it doesn't involve the small letter m. So when k approaching to 0, omega approaching omega minimum equal to 0. Then for k plus minus 2a at the boundary, so the phase velocity equal to omega over k. Omega over k, you just substitute k equal to pi over 2a into this equation. Okay, substitute pi k equal to pi over 2a into this equation, because we want to know when phase velocity v equal to omega over k. So omega is this one, then k is this one. Okay, substitute, then solve it, you get this one. Then group velocity, we have omega. So the group velocity is d omega d k. So you differentiate this one over k, nothing, you get 0. So the phase velocity equal to this equation, then the group velocity equal to this equation. Then there's a range of forbidden frequencies between the acoustic and optic branches where phonon do not exist. So you can see that at this region, these two regions, no omega will be exist there. Okay, no omega can occupy there. Means that it's a forbidden region. Okay, it's similar like the energy band gap. So we have energy gap that does not, that there's no any electron that can occupy that space. From here also same, there's no phonon can occupy this region. Okay, because you see that there's a gap there. So now we proceed to the optical branch. The name so-called optic branch because its phonon mode are excited by light of suitable frequency. So when k equal to 0, omega is equal to omega 3 equal to this equation. Okay, clearly we have shown, I have shown you this equation, right? So when k equal to 0, I substitute k equal to 0 in the previous equation, then you get omega equal to 0 and omega equal to this one, 2 mu times 1 over m plus 1 over m square of a. And then we name it as omega 3. Okay. So same thing, we have a equal to blah 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 and b equal to blah blah, the previous equation. Then you just rearrange the equation, you will get the ratio of b over a or a over b. Okay. Then when you substitute k equal to 0, this one equal to 0, and this is a very small and omega, you substitute this one into here. Okay, then after you solve it, you'll get B over A. You solve this equation, you get B over A equal to M, small letter m over capital letter M. And you will see the negative here. Okay, this negative indicate that the amplitude of the heavy atom always have the opposite direction with the amplitude of the light atom. Okay, so B over A is the amplitude of the heavy atom over amplitude of the light atom, and it's negative. It's negative for all value of K, no matter what value of K you substitute. It means that the nearest neighbor atom move in opposite direction. Okay, how to get this one? The dash box indicate the equation that we obtained previously lah. Okay, the dash box. Okay, so we have B over A equal to this one. Remember that? This one, we start from this one. And then for K equal to 0, you substitute cos Ka equal to 1 lah. Okay, cos 0, you get 1 lah, so you get 2 mu. And then omega equal to omega 3, you substitute this omega into here. Okay, you get this one. Then you solve it, you get B over A equal to small letter m over capital M. Or in other words, A over B, you will get capital M over small letter m negative. No matter A or B or B or A, you get negative sign here. And this negative sign here indicate that they move in different or opposite direction. Like small letter m moving up, then capital letter will move down. That's the reason why they have both different amplitude, opposite amplitude. This one is, let's say, positive 5, then this one negative 5. So when the ratio of m over capital M, you will get negative value. So when omega approaching omega naught, omega 2, so this one, just now I was discussing omega 3, right, this one, but now we have to discuss this point and this point, okay? For these 2 points, K equal to pi over 2a of negative pi over 2a, right? So omega 2 equal to this one equation, this equation, remember? Then the phase velocity omega over k equal to infinite, and then the group velocity d omega dk equal to 0. This one, no, this one, okay, not important. And the ratio of the mass of the light atom and the heavy atom, small letter and capital letter, determine the width of the forbidden frequency range, this range. So if you change the ratio of m and the light atom and the heavy atom, then you may get the maybe larger forbidden range. The second thing, the width of the optical branch, also this one. So for the first case, you get the width like this. The second case, you will get maybe like this, so larger width. Okay, so from this chapter, we can understand that the phonon is actually affected by the arrangement of the atom. For the first arrangement of the atom, all the same mass atom, so we get the first graph. And then for the second case, second model, we have the 2 different types of the atom, then we get this graph. Okay, so up to here, we can conclude that the phonon is controlled by the atom arrangement. That's the reason the first model and the second model will give you different dispersion relationship. Okay, then now